According to Polymaker, the CoPE may be a good alternative to the PLA. Is it? Well, it's time to check this. Welcome to another Polymaker filament testing video, this time from their Panchroma line. This is CoPE, a high-quality copolyester-based filament which is designed to improve the printability compared to the PLA. And this is not a sponsored video. I just got so many requests and I contacted the Polymaker and I thought I would got one spool, but instead of one they sent me 3 CoPE filaments, and also they sent me a PolyLite PLA filaments and 3 in the same color. A small correction, because that intro I recorded a month ago. In the meantime, the Polymaker became a channel sponsor, but this won't have any kind of effect to the main content of this video or to my measuring results. Now back to the video. CoPE is developed to improve the printability, like bridging overhangs. It can be printed on higher speeds. It have a similar print surface quality like the PLA. But being a polyester based, it is cheaper. Currently I can see approximately $5 is the difference. Of course this depends of the country and depends of the discounts, but yes, even now I can see that it is cheaper compared to the PolyLite PLA. Now be careful, because it may stick too good to the PI sheet, especially if you have some bigger surface. In that case it is suggested to use some kind of glue stick or other separation layer. Spools have hardened edges. This means it can be used with the AMS unit, but don't forget this is different material type and it will not stick too good to the PLA. This means it will stick good to the other CoPE material, but maybe we can use it as a support for the PLA. I can see many users are using PETG, for example, as a support material because it will not stick to the PLA, but the PETG have different printing properties, different temperatures, but here actually we can use existing profiles for the PLA, and this means we can print with the similar settings and we can use it for the support material too. So as I mentioned, mostly it will reduce the price and it will have better printability, but the mechanical properties will be reduced according to the Polymaker. So mostly I will test this printability. Yes, I will include some mechanical tests too, layer adhesion, tensile, sang and similar, but mostly I want to compare the printability, and since I have here same color pairs, we have a really nice comparison between these two filaments. About print settings, the nozzle temperature between 190 and 230 degrees Celsius, bed between 25 and 60, but don't forget if you have bigger surface, use some separation layer, and print speed up to 400 millimeters per second, and fan should be on, basically same like with the PLA, only here I can see they recommend even higher speeds, and drying only if necessary up to 55 degrees Celsius for 6 hours according to the Polymaker. Let's unbox one filament. Really nice spool with a lot of useful informations. Here we have print settings, weight of the anti-spool 145 grams, locking end of the filament, and this bag is resealable, only don't forget to cut it above the sealing line. Just quickly to check the PolyLite PLA spool because it was changed in the meantime. But I already saw this one, a cardboard spool. Here we have the print settings, locking end of the filament, and the bag is also resealable. I'm starting with Polymaker's Teal color and with the PolyLite PLA. Do not open from this side, very useful reminder because this side is bigger compared to this one, which is resealable. At the first look, colors are not exactly the same and the CoPE is shinier. Both are loaded into AMS light, but the printing I'm starting with the PLA. Filaments are not brittle until they are new. This is PLA and this is CoPE. This is more flexible, I think. I have to check this with the Polymaker. I'm not sure how to test it because I have the feeling that the PLA will become brittle by time, which is typical for the regular PLA materials, but I'm not sure about CoPE. This looks more flexible. Exactly from this reason I'm never leaving PLA materials inside the AMS because by time they will break inside these Teflon tubes. These are test objects for the layer adhesion, tensile, bending and impact tests, and I mentioned that I'm starting with the PLA. Bed adhesion check, and I know that it is good with the PLA on 65 degrees Celsius until the print surface is hot. I will wait until it cools down. The bed completely cooled down, yes. Bridging test, and it starts with the longest one. I will analyze these printings where all objects will be finished. The top is not bad, but from the bottom we can see some differences, but I will compare all test objects when they are finished. The overhang test, and actually the real overhang should go in 4 directions, but this is not a test for 3D printer, but for the filament itself. Okay, I have to stop here. I mean, pity, because I know that it should go higher. It curves up a little bit and it pushed off the object from the build surface. I'm reprinting this overhang test to see if it will fail at the same angle. I just catch the moment. Okay. Exactly same height. Polymaker scientist, and this is the first time I'm printing this test model. And the most critical part is this overhang here, but it's already printed now. Another important milestone is when this arm will be connected with the body, and it looks like it happened now. This is the first time I'm printing this model, and it really looks fantastic. This is CoPE. I'm using exactly the same settings, only one thing I changed here, and that's reducing the bed temperature from 65 to 60. I hope it will be enough, because I don't want to use the glue stick. Just quick bed adhesion check until it's hot. It's good. I hope it will be better when it cools down. Bed cooled down almost to room temperature. Ah yeah, this is fine. And funny. It started with the bridging, and at the first look it is very similar to the PLA, but I will compare them at the end, side by side. CoPE overhang test, and it's on that critical point now. Oops. It passed that critical point now, but I think it will stop here. Yeah, definitely. And there will be another Polymaker scientist, and that critical overhang is already finished. It's finished, the bed completely cooled down, and this is the first time I tried 50 degrees Celsius on a build surface. Because I experienced that it is a little bit hard to remove, even now. Next time I will try 40 degrees Celsius. I need a better overhang test. This is CoPE, and I rotated it in 90 degrees. And all settings are default for the generic PLA. In this case, except the bed temperature, it is 45 degrees Celsius. And soon it will be finished. This is the covering layer. Not so easy even now. And this is PLA. The progress is good so far. Oh, it just removed from the bed. It curls up and it was removed by the nozzle. Okay. Now moving to the gray color, and I will reprint everything. Only in the video I include the footage of the printing of this figure, Polymaker scientist. Also on this filament I can see that CoPE is shinier compared to the PLA. PLA. Will it be better than this one? No. CoPE Polymaker scientist, and the first layer will be printed on 200 degrees Celsius nozzle temperature and only 45 degrees Celsius on the bed, because I want to experiment a little bit more if I can reduce that bed adhesion with this filament. I will not be here when it will be finished, so it will cool down overnight, and I'm very curious tomorrow how hard it will be removing from the build plate. It cooled down overnight. Let's see if this method works. Acceptable. CoPE. And again with this material it's finished. And now moving to the steel gray color, and it looks like it is just a little bit darker than the regular gray. And this is CoPE, this is PLA. Again, CoPE is slightly shinier in both cases. And the color choice was not mine. I mean, I would choose, I don't know, more drastically different color like black or white instead of this steel gray. Steel gray filaments are loaded, ready for printing. And this PLA is the shiniest compared to the other two, but less shinier compared to the CoPE. PLA is still gray, and it will be finished without my supervision. And finished without problems. Still gray PLA, and usually it fits over here. Ah, I just missed the point. Okay. This is CoPE and it is on that critical height. And it is finished. But the printing was very critical at the end because it grows up a lot. This CoPE scientist will also be finished without my supervision, and tomorrow I will check the bed adhesion. The bed completely cooled down overnight. Acceptable maybe. I need one more layer adhesion test. I want to see how these two material types bond to each other. And this will be the reference material, PLA, printed with 2 watts and 20% infill. This is the second reference, CoPE. There was a color change and I hope it will bond to each other at least, so I can do this testing. So far it looks okay. It was finished correctly and I hope it will not break off until I get home, so I will be able to measure it. I want to experiment more with the bed adhesion. This is textured PI sheet which arrived with my P1P, and later it was replaced with this golden color, and usually I know that this has a weaker bed adhesion. Let's try this. The bed cooled down. Oh, much easier, definitely. The bed is still 45 degrees Celsius. Perfect. This is a little bit weak for the PLA, but for the CoPE, perfect. One more attempt. I have these 3D effect sheets from the Bamboo Lab and I wasn't too happy with the adhesion to the PLA. Let's see how it performs with the CoPE. The start is good and I'm using exactly the same settings like with the generic PLA. 65 on the bed and 220 on the first layer. Quick check until it's hot. Oh, almost too weak. But it has a nice bottom surface. One more attempt. This is the other side, so-called diamond pattern surface. Looks like the bed adhesion is bad with this material too. I have the feeling that this Prusa satin sheet will work fine too with this material, but let's give it a try. The start is good, but the purge line was almost too easy to remove, but we will see what is the case with the object. Unfortunately, the adhesion is too weak and you can see the legs are removed. Let's see, the bed is still hot, 60 degrees Celsius. Yes, it could be better. So satin sheet is not good for CoPE. And what about Prusa texture PI sheet? More promising. It's finished a few seconds ago. Bed adhesion is good. I will wait until it cools down. The bed completely cooled down. Oh, perfect. The maximal flow rate test, this is PLA, and I'm going from 5 up to 30 cubic millimeters per second, and at the end I will measure the thickness of the wall with this micrometer. It's speeded up now, 5 more minutes, and you can see how fast is the rotating of the spool, and I can hear the skipping of the extruder from time to time. Well, actually I will stop it here, this is not good for the printer. And now CoPE. It starts slowly, currently it's around 6 or 7 cubic millimeters per second. Currently it is on the same height where the PLA failed and I stopped the printing. This one looks better so far, but I have the feeling that I have to stop the printing soon. In most cases, definitely you don't want to print with this flow rate. And this time it was able to finish it. Even without measuring, this is PLA. And this is CoPE, which was finished, and I use the same G-code in both cases. Okay, let's analyze it better. This is PLA, and here I wrote the scale. This is in the flow rates, and I also measured the wall thickness in several points, and I was searching where it starts to the grade where it will reduce. But even without measuring, I hope you can see it visually on the camera too. Somewhere here it started with the color change too, but also here the wall is thinner, and it's approximately 20.5 cubic millimeters per second, the maximal flow rate for this PLA. For the CoPE, somewhere here the wall starts to be thicker, but also visually I can see that here this is under extrusion, and this is around 22 cubic millimeters per second. So the difference in maximal flow rate is not big, but as you can see the CoPE was finished up to 30 cubic millimeters per second flow, until that the PLA fared around 24. Now I want to check something. I placed here both filaments here a week ago when I started the testing, and they have some small tension on them. This is PLA and this is CoPE. So I believe that this may be a big advantage of the CoPE. It will not break so easily inside the AMS unit, unlike some older brittle PLA. Let's start with analyzing these bridges. This is PLA and this is CoPE. From the top there is no difference between them. From the bottom, no obvious difference between them. For the look, slightly maybe the CoPE is better, but try to decide yourself. With overhang test, the difference is more obvious because in all three cases CoPE was finished until the PLA failed a little bit earlier. But until the failure point, the quality is equal. This is gray color, and this is still gray. Polymaker scientists, it looks very similar in all 6 cases. It was very hard to notice any difference. Let me show you, I find one thing actually. This is CoPE, this is PLA, and only on this one small point I can see some minimal difference. As you can see, this bottom of this coat came out slightly nicer on the CoPE compared to the PLA. But as I mentioned, it is really hard to notice any imperfection here, and really they look very similar. This is gray color, and still gray. And these are gifts for my students next to my office, and I'm promoting here my 3D printing lessons. Using it as a support may be tricky because these materials have different adhesion to the bed. Maybe it makes sense to use CoPE as a separation layer only, even the printing time is shorter in that case. And just to see everything in a practice, currently it is changing the color. The support is CoPE and now we have 0 distance between the support and the object itself. Well, let's remove the supports. It's completely clean inside. Tensile test with horizontally printed test objects. 2 on the left is PLA, 2 on the right CoPE. This is now gray color. You can see the average values for one material type. And the last one still gray. In blue color you can see the PLA material, CoPE is in orange color, but basically the big average PLA was stronger by 23%. Layer adhesion test with vertically printed test objects. This is teal color. Gray color. 2 on the left is PLA, 2 on the right is CoPE. Still gray. And again you can see the average values for one material type. This time we have a huge difference here. The layer adhesion of the PolyLite PLA is fantastic according to my scale, and for the CoPE, well, it is acceptable. But in this case, PLA is stronger 2.6 times. Another layer adhesion test. These test objects have 2 walls and 20% infill. This is the average for the PLA. This is CoPE, noticeable weaker. And now combination of 2. This is weak, but as I mentioned, good for supports. A quick impact test with this machine, which is a little bit too strong for these brittle materials, but I just want to see if there is any significant difference between CoPE and PLA. I'm starting with the PLA. This means CoPE is slightly more brittle material compared to the PolyLite PLA, and here you can see the numbers, the breaking energy in the joules. 3-point bending test, distance between supports 64 mm, and I will just place this 5 kg load and I will measure the deformation after exactly half minutes. For the PLA the average deformation was 1.47 mm and for CoPE 2.01. Visually there is no permanent deformation on any groove, but this also means that the PLA resists better to the bending compared to the CoPE. Temperature test in the oven just to see if CoPE performs similar like PLA, and they both started to deform around 55 degrees Celsius. CoPE was slightly better, but after this, for the filling, it was equally soft like PLA. For the touch, no difference. This was much bigger work than I expected, not because the Polymaker became a channel sponsor, but because this is new type of the material. So I can see two disadvantages. One is the weaker mechanical properties and weaker layer adhesion. And the other is that it may stick too good to that very popular golden color textured PI sheet. And I can see three big advantages. One, the printability, it is better than the PLA. The second, it is cheaper compared to the regular PLA. And the third one, I can see that the filament itself is less brittle and there is a less chance that it will break inside the Teflon tube in AMS unit or something like that. So this was my experience with the CoPE. Big thanks to the Polymaker and to my Patreon supporters because they make this kind of videos possible. And a friendly reminder, if you like this kind of videos, you should subscribe and enable that notification bell button too, because in most cases my videos are not really recommended to new users, only to those who enable that notification bell button. I can see the statistics, so basically 80% of you already did that. Anyway, thank you for watching this video and happy printing!